is a tutorial process. We are going to talk about events. Event can be defined as changing the state of an object or behavior by performing actions. Actions, they can be a button click, a cursor movement, key press through keyboard, or page scrolling. Then classifications of events. We have foreground events, background events. Then these are the diagrams of the types of events here on the screen. Let me welcome my colleague Irene to talk about.
This is Irene. I'm going to talk about foreground events and background events. Foreground events are the events that require user interaction to generate. Foreground events are generated due to interaction by the user on components in graphic user interface. Interactions are nothing but clicking on the button, scrolling the scroll bar, cursor movements, and many others. Then background events that don't require interactions of users to generate are known as background events. Examples of these events are operating system failures or interrupts, and operation complete. Event handling. Event handling is a software routine that processes actions such as keystrokes and mouse movements. It is the receipt of an event that adds some event handler from an event producer and subsequent processes. Then another one, there are functions of event handling. One, event handling identifies where an event should be forwarded. It makes the forward event. Then it receives the forwarded event. Then it takes some kind of appropriate action in response, such as writing to a log, sending an error, or recovery routine, or sending a message. Then lastly, the event handler may ultimately forward an event consumer. Let me welcome my friend Immaculate to say something.
Immaculate presenting the event handlers and their description. On a bot, it executes when the user aborts loading an image. On Bluer, it executes when the input focus leaves the field of a text area or a selection option. On Change, it executes when the input focus exits the field after the user modifies its text. On Click, in this, a function is called when an object in a button is clicked, a link is pushed, a checkbox is checked, or an image map is selected, and it can return false to cancel the action. Then an error, it executes an error when an error occurs when a document or an image. Then on Focus, it executes when input focus enter. Then on Load, it executes when a window or image finishes loading. On Mouse Over, the JavaScript code is called when the mouse is pressed over a specific link or an object. On Mouse Out, the JavaScript code is called when the mouse leaves a specific link or an object. On Reset, it executes when the user resets a form by clicking on the reset button. On Select, it executes when the user selects. Then on Submit, it calls when the form is submitted. Then on Unload, it calls when a document is exited. Let me call Simon to add on.
This is Simon Peter presenting delegation event model in Java. This delegation event model is defined as a handled event in graphical user interface programming language, that is GUI. That is graphical user interface, where a user graphically or visually interacts with the system. The graphical user programming is inherently event-driven. Whenever a user initiates an activity, such as a mouse activity, a click, scrolling, etc., each is known as an event that is mapped to the code to respond the functionality to the user. This is known as event handling. In this section, we will discuss the event processing, as we are going to see down diagrammatically. Event processing in Java. Java supports event processing since Java version 1.0. It provides support for LWT, which stands for Abstract Windows Toolkit, which is an API used to develop the desktop application in Java version 1.0. The Abstract Windows Toolkit was based on inheritance to catch and process graphical user events for a program. It should hold the subclass, which is a child class of a graphical component, and override action or handle event method. This is as demonstrated on the image of event processing. This is the diagram of event processing. You see that the event source is revoked to a listener object. Then it goes to listener interface, where we see on event, as we have seen on the event handling, whereby a listener object registers an event source. Then an event source creates an event object. So from there, this is a simple explanation for the above diagram, but the model approaches for the event processing is based on the delegation model. It defines a standard and a compatible mechanism to generate and process event. In this model, a source generates an event and forwards it to one or more listeners. The listener waits until it receives an event. Once it receives an event, it is processed by a listener and returns it, as we have seen here above on the diagram. Then the elements are able to delegate the processing of the event to the separate function. The key advantage of the delegation event model is that the application logic is completely separated from the interface logic. In this model, the listener must connect with the source to receive the event notification. Thus, the event will only be received by the listeners who wish to receive them. So the approach is more convenient than inheritance-based event model. Thanks for listening. Have a good evening.